Hi friends, so this is the third video of current electricity chapter. So today I am going to solve numericals on the concept called electric charges, current as well potential difference also. Okay, so here I have written a question. Let me read out the question. A current of 0.5 ampere drawn by filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. Okay, so this is what your question. See, first and foremost thing, we are supposed to write given data. First and foremost thing, we are supposed to write what? Given data. Okay, see what they have given here, 0.5 ampere, right? So ampere is nothing but unit of what? Current. So I am going to write it as what? I equals to 0.5 ampere. Okay, next 10 minutes, isn't it? So that is nothing but T. T equals to what? 10 minutes. So the minutes is not in the standard value. The standard value is the standard is what? Seconds, isn't it? So need to convert it into seconds. So 1 minute equals to what? 60 seconds. Okay. The same way 10 minutes equals to, that is 10 into 60. What it is? 600 seconds. Okay. Next, find the amount of electric charge that flows through the circuit. So electric charge is nothing but what? Q equals to what? Isn't it? Q equals to what? So our formula is what? I equals to Q divided by T. Our formula, basic formula is what? I equals to Q divided by T. Isn't it? We are supposed to find what? Q. So Q equals to I into T. So I means what here? 0.5 into T is what? 600. So 5 divided by 10 into 600. Okay. So just I have converted this decimal from decimal. So 1 0 and 0 get cancelled. That is 6 5s are 30. So that is nothing but what? 300. This is what? Charge. That is nothing but coulombs will be your answer. So Q equals to what? 300 coulombs is your answer. Okay. Okay, here is the second question. Calculate the number of electrons constituting 1 coulomb of charge. So we are supposed to find what? Number of electrons. Okay. From 1 coulomb of charge. So we know that formula Q equals to N into E. Okay. Where Q is nothing but what? Charge. Okay. N is nothing but what? Number of electrons. Number of electrons. Where E is charge of electron. It is charge of electron. Okay. So these are the things. See what we are supposed to find actually, that is number of electrons, right? So what we are going to get it as, that is nothing but Q divided by E equals to N, isn't it? So that is nothing but N equals to Q divided by E, where 1 coulomb of charge they have mentioned, isn't it? So what I can write it as 1. Okay. Where E is nothing but what? E is nothing but what? Charge of 1 electron. So charge of 1 electron is nothing but what? We know that value 1.6 into 10 raised to minus 19, isn't it? So we have substituted the value. Now just calculate the values. So which is nothing but we are going to get approximately, that is 0.65 into 10 raised to 19 electrons. Okay. So if I shift this point, 6.25 into 10 raised to 18 electrons. So this is what our Q, sorry, I mean N, that is nothing but number of electrons value. Okay. Okay, so here is third question. See, this is based on electric potential and potential difference. That is nothing but how much work is done. Okay, so the question is based on how much work is done with respect to electric potential and potential difference. Let me read the question. How much work is done in moving a charge of 2 coulombs across 2 points having a potential difference 12 volts. Okay, so first let us write the given data. Okay, so what they are asking, how much work is done. So they are asking us work done, right? So let me write work done equals to what? Okay, then 2C, that is nothing but what? Charge. They are asking, I mean they have given charge, that is Q equals to 2C across 2 points having a potential difference, that is V equals to what now? 12 volts. Okay, so they are asking us to find what? Work done. So what is our formula? V equals to work done, that is nothing but WD divided by Q. Okay. So we are supposed to find what? Work done. So work done equals to V into Q. Okay. So what is V? 12. Into Q is what? 2. Okay. So 12 twos are 24. So we are supposed to keep here unit. Okay, in the previous video I have said work done is nothing but we can treat it as what? Energy, right? So a unit of energy is what? Joules. So here I am going to keep it as what? Joules. That is nothing but work done equals to 24 joules is here answer. Okay, the next question is how much energy is given to each coulomb of charge passing through a 6-volt battery. Okay, so what they are asking us to find how much energy is, right? So energy is nothing but just now we came to know that is nothing but I can call it as work done, right? So energy I am going to write it as what? Work done. Work done equals to what? Okay. So to each coulomb. So coulomb is nothing but unit of charge. So each means what? 1. Okay. So that I am going to write it as what? Q equals to 1C. Okay. Passing through a 6-volt battery. So that is nothing but potential difference is what? V equals to 6 volts. Okay. So what is our formula? First let's write the basic formula, that is V equals to work done divided by charge. Work done divided by what? Charge. Okay. So what we are supposed to find? Work done, isn't it? So work done equals to V into Q. Almost it is similar to the previous numerical. So V is 6 into Q is what? 1. So which is nothing but 6 into 1 is 6 joules. As I said in the previous problem, work done is nothing but what? Energy. So 6 joules will be the answer. So this is the 5th question. Define 1.5 volts. So I have written already the answer. 1.5 volt means that there is a potential energy difference of 1.5 joules per coulomb between the points. So this answer is nothing but based on yesterday's topic, that is potential difference only, where the 1 coulomb of charge moves from one point to the another point in a circuit. The same answer with example of what? 1.5 volts.